Hello, I am Eric Miskell with EMSNOW, and welcome to this webinar from Co-Young America titled The ABCs of API. And API, of course, stands for Automated Pin Inspection. We thank you for joining us today in what should prove to be a very informative session. The goal of this webinar is to provide the audience with a better understanding of the Co-Young API machine and its capabilities and applications. Our presenter today is Gustavo Jimenez, who is the Mexico Sales Manager at Co-Young America. The structure of the webinar is that I will be asking Gustavo some prepared questions to guide us through some informational slides. After that, we will field any questions that the audience wishes to pose. Some quick housekeeping issues is that all guests will be on mute throughout the entirety of the webinar. This session is being recorded for future rebroadcast. And if you have any questions or comments to share, we ask that you submit them using the question icon at the bottom of your screen there. So that all being said, let us begin. Gustavo, welcome. Good to see you again. Why don't we begin by allowing you to introduce yourself for the benefit of our audience?
Thanks. Well, first of all, thanks for the space here, Eric. We really appreciate these channels to communicate with our customer. And I believe there's good information to share. I'm Gustavo Jimenez. I work for Co-Young America as a sales manager in Mexico. I've been working for this company for 4 years now. So happy to be here, and I'm happy to share this information with you guys.
Good. Now let me get the slides prepped here so that I can do this appropriately. As indicated, there are several questions that we're going to go through, but let me just kick it off with Gustavo. So Gustavo, the specific machine we will be discussing is the Co-Young's KYP3 system. Correct. Is KYP3 an actual AOI machine?
Well, even when there are too much similarities with their AOI systems, this machine is not an AOI. This machine was designed as an automatic optical inspection system, but their design is based on the ability to inspect terminals, pin and terminals. So we call it an automatic pin inspection machine. There are many differences. The most important difference with our AOI system is the hardware, the way we accommodate the projectors, the way the angle of the projectors, the camera is different. It's a different setup than our normal AOIs. And we do that because we firmly believe that you need those differences in order to have a proper inspection with a pin, because it's not the same, right? The shape of a component for SMT process is way different than the shape for a terminal, right? So there's no way to have a proper inspection results if you're using the different setup in your machine. So we figure out the way to have a better, repeatable and accurate inspection with terminals, but we need to use this different hardware. So the answer for your question, Eric, is not an AOI, it's an automatic pin inspection machine, an API. That's the way we call it.
Okay, well, that makes sense. Well, given that it's not a conventional AOI, what is the scope for an actual API then?
Well, that's a very good question, because we are sometimes in this industry, we are very focused on the front end or the SMT process, and we are very successful there. But there are other parts of the process, talking about the backend assembly, when especially in these days, there are more and more inspection requirements. The new products, the new parts demand higher inspection capability for backend as well. So even when this machine is capable to inspect hybrid boards like SMT with terminals, usually we are running this machine in the backend area. And since we will see that in the coming slides, but the machine is very flexible, so you can accommodate from a normal line to a manual loading area, and you can get the same results. So when you usually locate this machine is in the backend process. Whenever if it's automatic line or a manual loading line, we can work with this platform.
Interesting. So it's capable then of inspecting any assembly with pin, terminal, or through hole?
Yeah. Any assembly that has a terminal, doesn't matter where that terminal is, can be inspected with this machine. And I mean that doesn't matter because we can find those terminals in a normal PCB for a pin-based process, or we can find those pins or terminals in a connector for connector manufacturing, or we can find those pins or terminals in a final assembly for an automotive product, or we can find that assembly on maybe a military design connector. There's many different packages or different products when you can find a terminal, and we create this machine to be able to inspect those terminals. Doesn't matter where, from PCB and final product, connector, through hole assembly. You know, through hole has also terminals. We can cover a very wide range of assemblies with this machine.
Interesting. And I'm just looking at what it says here, the shadow free with 3D projection from 4 different angles. So that's what's being, the image there is demonstrating there, right?
Yeah, we use, as I said, we use a very similar technology than our SPIs and AOIs. We have this projector that create a moire, and the image, the camera is getting that information and converting it to 3D render, so you can inspect. You can get all the let's say the real situation in the board. You can get it in 3D, and then you can apply many different inspection conditions.
Okay, interesting. So talk about the defects then. What type of defects on pin terminal can the system then detect?
Well, the defects that we can find with this machine, they are similar to what we can do in SMT, but we also can check the pin quality, right? If the pin was inserted in a proper way, if the height of the pin is the correct, if the coplanarity between the pin shoulders is the same or is correct, the angularity of the pin, it doesn't matter if it's X and Y or an angle. And sometimes we have these customers that tell, hey, I need to know the pin, the distance between certain reference, or we need to make sure that there's this X distance between pin and pin or between all the pins. So we can play with that, and we can provide similar results in accurate and in repeatability than on SMT systems. So you can see in the slide different failure modes. If for example, for a 4 terminal, when you have these 2 terminals, we can determine in a very accurate way what's the distance between these 2 pins, because that's a quality requirement. Eh? You need to comply with this X distance. Well, we can know in a very good way what's the distance between those 4 pins. So many different failure modes that can be done by this machine.
Mm-hmm. So is it, I mean, part of this is the whole through hole technology inspection. So what about that? How is that handled?
Yeah, that's something that is becoming more and more popular in these days. Uh, what about the throughput, the through-hole process, right? Usually, this process is being being a lot of changes because you easily get started as manual assembly. Then we have very unique equipment that can place that components and that can solder in an automatic way. Well, especially for the automotive industry, they are the manufacturers. They are starting to see this requirement for their end customers that are they have similar needs than SMT. So since we have our experience with SMT plus the ability of this machine to inspect terminals, well, that's a very good combination to have good results on the through-hole inspection.
Mm-hmm. And just out of curiosity, as far as the speed of the unit and how quickly you can actually do this, I'm looking at some of the boards that are here, right? There's a lot there. So
Yeah.
how quickly does the board, does the system do its job?
Well, that's a very good question because you need to keep up with the production rates, and for sure you need to maintain a certain speed on the inspection. This machine has the 4 megapixel camera with a micron size of 50 microns. But if you need a little bit more speed, you can equip the machine with the 8 megapixel camera at 20 micron pixel size, and that's super fast. For a normal automotive assembly, we can inspect in less than 50 seconds.
Oh, wow.
15 seconds, yeah.
Okay.
Wow.
Okay. Talk about
and sorry, Eric, I forgot to mention in the through-hole process. Sometimes, especially when there are some high pod assemblies, that you have this high power electronics like those capacitors. Well, we can, as an option, we can make the top and bottom clearance of 70 millimeters. So you can put these boards with super tall components, and machine will be able to inspect them. We can reconstruct in 3D up to 25, but there's a lot of other applications other than 3D that we can other inspection that we can do in the 2D area as well. So that's good because you have this. We are starting to see that this machine is very flexible, and since I think that's not a nice to have, that's a requirement in the backend area. If you cannot be flexible there, then I don't see how you can contribute to the inspection. Sorry.
No, that's excellent. I appreciate that additional comment. So talk about that. What type of defects then on through-hole can the KYP3 then detect?
Yeah, well, for the top side of the assembly, well, we can do almost anything. We can measure 20 up to 25 mm for tall parts. We can measure polarities, coplanarity, but overhang, many different inspection conditions. But in the bottom side, we are very capable on see how good is the solder, because we know when we're using this selective soldering or wet solder, it's not easy to control. Sometimes it got a little bit complicated. So we have these software tools to determine how good is your solder process, to determine if there are solder balls that are in the PCB, to determine if there are short circuits, if there's not enough solder, if the solder fillet is within the specs, class 1, class 2, class 3. You know, but that's very important for a system like that has the ability that to determine the quality of the solder process, which is very important for this through-hole technology. So as you can see in the images over there, we can see that we can inspect usually many of the inspection in this area is 2D. Well, we can do it in 3D. We can determine if the soldering quality is within IPC. doesn't matter the class. We can see how good is the solder fillet. We can see if there are enough solder in the circumference of the terminal. Well, we can cover most of the common defects in the through-hole process.
Okay. And does the type of solder, and it works with all types of solder, the type of solder?
Yeah, that's a good one, Eric, because sometimes when you have different alloys, there are more or less brightness. So we have this machine has 3 different RGB lighting rings, and we have 9 different channels. So we can make a lot of adjustment to our lighting in order to don't be heated by the interreflection of the different solders. So doesn't matter what alloy, as you know, having the ability to adjust the lighting is the key to inspect this. So we can do that. We're the only company that has that 9 different lighting channels in our equipments. So we can apply that to the solder inspection.
Okay, good. Thank you for that. So I know you touched on this before, but I do want to revisit it. The issue of where is the system usually located in a production environment? Yeah,
usually we go outside the SMT site. As I told you, even when the system is capable, and we've been selling these systems also for. Let's give it an example. I have this customer that has a hybrid technology, right? They have a board for relay box, and they are placing these terminals with a special pick and place machine, but they are also placing some SMT components. So for that, in that case, if you have, and that is impossible to inspect these terminals with a normal AOI. It doesn't have the capability. Even if we compare our own AOIs versus KYP3 inspecting terminals, we have a better performance with the KYP3. So we can do this hybrid inspection even in the SMT line, or if you need to go outside of the SMT, we can inspect there. But in order to provide a solution for the backend, the key is be flexible. And I will touch on that later. But this machine is very flexible. It's the most flexible inspection system in the industry, because as I tell you, this was designed for pin inspection, for backend. And if you need to provide a solution there, you need to be flexible. And we are very flexible. And we will see that later.
Okay. So, and I get that all, the different formulation of a line depends on what's being built, as you're saying, if it's, something simple that's just running through constantly, or if it's a hybrid or whatever. So yeah. You have to work with the particular client to integrate this within their line and their specific environment.
Right.
Okay. Makes complete sense. So what type of assemblies can the platform then handle?
That's the key question, Eric, because yes, we have the normal machine, which is our A1 model. That's the handling system is very similar to an SMT machine, right? You can communicate through SMEMA with the other with the previous and post process, and that's let's say that's the normal. But what if you need to inspect an assembly that is running on an automatic line, but it's a final assembly? Well, the way to handle those assemblies is different. Well, we have the A3 machine that is capable to carry maybe a final assembly that is over a pallet, or so we can use that machine. Very different handling structure, but we can still doing it. But if you have a PCB that maybe it's now being loaded manually by the operator, we have also a machine, the M1, that's a machine that can be can process PCBs, but with manual loading and unloading. No, and you can, for all the machines, share the same inspection proof, the same, they have all the same inspection capability. What makes them different is the way to load the PCB. So the M1 is manual loading for a PCB, but the M3, if you have this back-end line, and you maybe need to inspect in a final assembly that has terminals before you pack it to send it to the end customer. Well, we have the M3. You can place a complete final assembly. You can place it over there. The machine will have the ability to handle that machine, that piece. And doesn't matter if that assembly has different axes, has terminal on different axes. We have machine that can move internally a piece so it can be inspected for all the 3 axes. So that's M3. So A1 normal machine for automatic line, A3 machine to inspect final assembly in an automatic line. M1 is for PCB inspection with terminals, manual loading, and the M3 is for manual loading for final assembly. So this is where I tell that we are very flexible, because if you see, we have more than one option to load the piece to be inspected. And this is a requirement, because in SMT, we know there's always the same SMT, automatic line with this MEMA or maybe Hermes or a different thing. But in backend, the rules are not right. You can do your backend process whatever you feel is better for your company. So we can accommodate this machine. Doesn't matter what's the production environment in backend, and that's where we are being very flexible.
Okay. And did I see this correctly? Are there 2 versions of the machine? One is kind of a single, one is kind of a dual line one, or?
Yeah, for M3, it depends on the customer inspection needs. If they need to keep up with production, we can have this M3 with dual gantry, while one piece is loaded in one side of the machine, the other one can be inspected. So we have this dual gantry production, and even when it's manual loading, we can make it very fast. And again, that's that machine, especially the M3 and the A3, we are very open to customize. If you have this customer for an EV manufacturer, they were having troubles because they have the need to inspect this final assembly, which has connector in, let's say, in the top, in the front, and in the left. So they were having hard time trying to find a single machine that can inspect this. They were touching base with most of the players in the inspection, and they came with us, and we adapt the M3 to be able that the operator load the part in the front, then the machine put inside the piece, inspect one part, then goes to the moving area, turn it, inspect, then goes to the moving area, turn it again, and inspect. So we can do that level of customization on this machine, depending on your needs and depending on the final assembly shape. Sometimes it seems impossible, but we can make it for sure.
Well,
yeah,
good.
Yeah, for this, because in SMT there's no you don't need to be to have a customized solution, because I mean the production is quite of very similar standard. But in backend, if you want to be competitive, if you want to provide a real solution for inspection in backend, customization and it's a requirement. Flexibility is a requirement, and we have all that in this family system. So I think, and we are being very successful in the commercial part with this platform. Is being in the market for 2 years almost, and we've been
Okay.
selling multiple systems in all around the world. And most of them, they go to the automotive industry, and a good part of them go to the EV manufacturing for automotive. So I think we are in the right path, and we are providing good solutions to our customers in that part.
Excellent. What happens if the assembly to be inspected has different height levels incorporated?
Well, that's part of the flexibility I'm talking about, and that's also part of the fact that this machine is a unique design for inspection, for pin inspection, because in a PCB for SMT we only have one zero ground or one baseline. There's only one, but in the back end or in the through hole or in the final assembly, there can be multiple C planes or zero planes. So this machine has the capability to move the head, to adapt the head height, so we can adapt different heights on a single product. You can adapt this height even from field of view to front of view. If field of view one has zero ground and the second one has a 0 plus 1 plus 5 millimeters, we can do the jump and adjust, so we can inspect in a proper way the focal distance, the 3D reconstruction. We can adapt that, so you can have that extra capability. And this is part of being flexible, right? Because if you don't have this kind of tools, I don't see how you can adapt to customer needs in this backend area. Because I mean, you know, and look at the examples over there. The shape of the board or the shape of the assembly is very diverse. There are many different combinations, and by having these tools, you can adapt to those needs. And I believe that's part of the machine success, that we are being able to adapt to that customer needs by utilizing these kind of tools.
Yeah, very good. Thank you. Yes, and does the K-Smart suite that Ko-Young offers also apply for the KY P3 system?
Yes, actually yes. And this is very good because most of our users are taking a lot of advantage of having the K-Smart tools in the SMT area. With these tools, the K-Smart tools, well, the first step is have accurate measurement, right? When you do it accurate, you can a lot of data. If you utilize that data to provide you power to make correct decisions, to anticipate to things, I think that's add extra ability to make to be successful, because we are utilizing that data not only to detect defects, but also to make the fine-tuning a lot more easy, to connect to previous process to improve them, to provide customer with the ability to control the machine remotely, to provide customer with information in real time to take decisions, and all that tools that we have present in our SMT solutions are present also in KYP3. All that can be applied to here. All of them are available, and our users they can confirm this, because this is giving or the user, this is giving them a lot of more power to take decisions and to maintain good performance of the machine, and that is applicable. You can connect this machine to the same server that you have in SMT with no issues. You can control libraries, you can control jobs, you can control any change that is being made through the system or through the machine, and you can have more visibility to control, to measure your process. So yes, the answer is yes, Eric. All the models that our customer already know for our AOI and SPI are adapted to KYP3, and they can take advantage of that in their facilities.
Yeah. And I ask that because, you know, your existing customers obviously are aware of the K-Smart, but when somebody is buying it, a new potential customer, you know, that whole smart factory solution part that brings into it is very powerful and a great additional benefit that you get with the machine.
Yeah, sometimes I feel that like we are very focused on the smart factory, but only in the SMT process. So we need to apply that to the whole manufacturing process in order to have a better control and better results. So that's our plan, right? Doesn't matter where the application is. We don't care if it's SMT, backend. We will provide customer with this tool so they can have the full control of their lines and they can have better results at the end of the day.
Gotcha. I am going to, this will end the slide part. So I'm going to just cut us back to our screen, hopefully. I think I did that effectively.
Yes.
And just to check, thank you, those were excellent. As far as the, you touched on it, the application, especially with PIN, when you think about this type of thing where pins are involved, you think automotive sector primarily in this country. You talked a little bit about that, but talk about that. And you also mentioned the EV industry as important within that too. Tell me a little bit about that.
Yes, well, we are seeing, and you are aware, and I'm sure that our audience is aware, that there's a trend that is making EV manufacturing more and more aggressive. Actually, there are countries that are telling the manufacturers that they need to switch to electric vehicles in certain time, right? So I think we will see this more and more, and we are already seeing that in the manufacturing sites here in Mexico. Most of them are, some of them are switching already to electric manufacturing for those brands that are making only EV vehicles. But even the traditional brands, they are switching to solutions that are present in the electric vehicles, and that means that they are in the way to transform their offer to these EV vehicles, and that is providing the industry with a lot of jobs, because even the traditional manufacturers, they are using features that are present in the EV vehicles, such as autonomous driving, semi-autonomous driving, super cruise. Those are concepts that previously were present only in the EV, but they are being adopted to the traditional cars. And I think that's their way to start thinking of switching to EV as well. So bottom line is that we will see an expansion of the manufacturing of electronic devices for the cars, and that's good for everything, because that will keep on the industry. And I think that's positive, because most of those features are related to safety. So I think by having those tools or those functionalities on the cars, we can make it a little bit safer for all of us, which at the end of the day is good. So that's what I think, and at the same time we will keep busy manufacturing those assemblies. So I think that's a win-win situation.
Right. No, and I appreciate that. And the idea of the automotive, because automotive industry obviously is a big one in Mexico, which is where you're selling these too. So I would imagine that, you know, it's a target-rich environment for you, right? There's a lot of companies and a lot more probably coming in as we watch EV grow in importance in the years ahead.
Yes.
Yeah.
Yeah. So yeah, we are very lucky in Mexico, because together with the US, we are seeing that expansion from time to time. Talking about the automotive industry, they are more dependent on electronic solutions. And those electronic solutions are being made and by us. Co-Young, or first industry, if we can call it that way, that we are selling more to automotive than to any other industry. Automotive, industrial, so that's very positive for us as well. So it seems that we will have some, we will be busy for a long time, which is good.
Yeah, I think you will be. I think you will be. Well, Gustavo, thank you for your time today. Thank you for explaining this. I think this was very informative, and I think the audience will appreciate it. We, of course, will. This is being recorded. We will be rebroadcasting this for the benefit of the audience, so more people can see it. And we encourage anybody who sees it to share it with anybody within your sphere that you think might have an interest or is doing any type of assembly involving pins, especially, right? So
no. Thanks to you, Eric. Thanks for making this possible, and thanks for all the audience. And if you have any further questions, or is there anything that you would like to know, you can contact myself directly, of any of our representatives all over the world. We are all over there, so we will be happy to provide additional information if needed.
very good. Well, Gustavo, thank you again very much. This was great. I appreciate you.
Thank you, and thanks to all the audience.
Yes.